We're looking at one of the most reactive metals. So we have sodium plus oxygen giving us sodium oxide. So we have Na, that is sodium plus oxygen giving us Na2O, that is your sodium oxide. So do you think it's exothermic? Look at the table. Sodium is on the leftmost column and oxygen is over here. So we have sodium, oxygen. We are basically writing the reactants and the product. And all the atoms that is involved in the reaction, we are writing on the first column. And then we are mapping sodium. In sodium is 1, there is no oxygen. In O2, there is no sodium, but there is 2 atoms of oxygen. In Na2O, where we have 2 atoms of sodium and 1 atom of oxygen. Is it balanced? Clearly not. So this has to be 2. So if for oxygen to be 2, your sodium oxide has to be 2. There is no other option. So if Na2O is twice, there are 2 of it. So basically you're looking at sodium to be 4. And to balance on the LHS, we have to make sodium to be 4 over here. And so 4 sodium plus O2 will give us, correct, 2 Na2O, which is a solid. This is a gas and this is a solid. So this can occur at room temperature. Okay, so let me change the color. This can occur at room temperature. That is, we don't need to supply anything. Okay, guys. So yeah, forgot. That's the main thing. And this is exothermic. So this too, we can look at the reaction. Practically, we look at it and it will make sense. So it generates heat and potentially can ignite the sodium as well. We can get to see that. Okay, when we do it with water, actually, it's a lot more clear. Now, main indicator is heat being released. So this is basically an exothermic reaction. Again, it should be very simple, or it is that obvious when we look at the table. You need to have a look at the table, understand the table, use the table. Next, actually, when you expose it to air, what happens? It's supposed to be shiny, actually. It's supposed to be kind of shiny and gray, silvery and bit gray. You get to see that in practicals. So sodium, when it reacts to form a white, or a bit grayish white, actually, solid of Na2O. Why is it Na2O? Look at the valency. We need to have 2 of sodium to satisfy 1 of oxygen. So Na2O. See, so much can be done with just a small table, is it not? So clearly we have Na, which is of metallic bond, a soft squishy material, and O2 is covalent bond, right? And we have NaO to be ionic bond. Because look at the difference. I'm sure the difference will be huge. I actually didn't even look at electronegative values, but since they are at the extreme left and another is not the extreme right, but still you can imagine they have to be ionic bond. Now let's finish this up with looking into the oxidation and all of that. So what is getting oxidized over here? See guys, this is the reason, because it's exothermic, you have sodium chunks stored in a very particular way and never close to water. Okay. Now sodium, which before and after I'll write. I need to mention this. Sodium, which in its oxidation state is 0, while your Na2O, it moved from being 0 to +1. So what does this imply? It lost an electron, a single electron. This is how it gets oxidized. That's why I tell that this is oxidized, not reduced, oxidized. It's a lot easier to understand with set of experiments. So yeah, let's have that as well. Please don't write this exothermic. This is heat.